So this is the Galilean transformation, right? Galilean transformation. The Galilean transformation says that x prime equals x minus vt and u prime equals u minus v. That's the Galilean transformation, and that tells us how to transform kinematics from one frame of reference to another frame of reference, from a stationary frame of reference to a moving frame of reference. So we can now transform measurements between frames of reference. We can take another derivative, go from position to velocity. I just took the derivative of x prime and x. So I can just take the derivative. What is du prime dt? Du prime dt is equal to du dt minus dv dt. Let's now identify each of these variables. What is this variable? What is this variable? This is the acceleration as measured from the prime frame. The acceleration of an object, right? So we have somebody moving, right? And maybe that person is accelerating, right? They're speeding up and slowing down, right? Maybe they're accelerating and as they're moving at a given position. So that's the acceleration of an object. It's not the acceleration of the frame because u is the object. What is this variable? That's the acceleration of the object in the unprimed frame. What is this variable? This is the acceleration of the frame, of the inertial frame. But what's the acceleration of the inertial frame? The acceleration of an inertial frame is, by definition, it's inertial. It's not accelerating. It's zero. So what does this second derivative tell us? This second derivative tells us that the acceleration measured in one frame is the same as the acceleration measured in the other frame. That's a really important fact. That's what tells us that a force measured in one frame is the same as the force measured in another frame, right? Because F equals ma. Masses don't change in two different frames of reference. So F equals ma, so the forces are the same. That tells us the physical laws are the same, that we don't have to make up forces in inertial frames of reference. Here's something really interesting, though. If this is a non-inertial frame of reference, right? If this is a non-inertial frame of reference, that means that frame of reference accelerates. That means dv dt is not zero. It's the non-inertialness, the non-inertialicity that gives us, right, the acceleration of the frame of reference that makes it look like the acceleration of an object in the moving frame is different than the acceleration of the object in the unmoving frame, because the moving frame is accelerating, right? That's just for a non-inertial frame. That is not what we're talking about here. We're only talking about inertial frames. But it's just interesting to see what happens if we move into a non-inertial frame. In a non-inertial frame, acceleration is not what's expected. And what that tells us is we have to make up forces in non-inertial frames because acceleration is not what is expected. Okay, but anyway, Galilean transformation is this. Great. So here's where the really cool stuff is, right? Here's where the really cool stuff is. Let's say that you got a light bulb. Whoops. Let's say you got a light bulb, and light is coming at, right? So it's a light bulb, it's in a lamp, and Susie is happily sitting reading a book. I'll give her a book, I don't know. And the light is coming at Susie at some speed we'll call c, right? C is the speed of light. Doesn't matter what the speed of light is. The light is coming at Susie at speed c. She's just sitting. Nah, she doesn't look like she's sitting. Put her in a chair. Okay. She's sitting reading a book. So what is the speed of light? The speed of the light relative to Susie. The speed of the light relative to Susie in her stationary frame is equal to c. So now, let's say that Susie gets out of her chair and goes to turn off the light. So Susie, let's make Susie the inertial frame of reference. Whoops, I took off part of her face. Okay. Susie is an inertial frame of reference moving at speed v relative to light. So Susie is now going to turn off the light. What is Susie's new velocity? What is the velocity of the light? Sorry, the velocity of the light relative to Susie now. The velocity of light relative to Susie now is c plus v. Right? That's a Galilean transformation. that the light relative to Susie stationary is C, relative to Susie moving is C plus V. If she was moving away, it would be C minus V. But anyway, I think you see it's C plus V in this case. So there's nothing wrong with that analysis, right? Nothing wrong with that analysis at all. I mean, that's like a car moving down the road. A car is coming at you at speed C. And when you're stationary, if you're moving towards it at speed V, then the car is coming at you at C plus V. We just did that on the other page. Nothing wrong with that. But what Einstein recognized is that Maxwell's equations don't work this way. When you take Maxwell's equations and you try to transform them using a Galilean transformation, Maxwell's equations, Max says that U prime still equals C. We'll talk about that next, why that's true.